Hello, my wonderful viewers. I'm Samuel, your maths tutor. I'll be taking you through mathematics topics across various levels of education. So you'll be looking at mathematics topics in the primary school, mathematics topics in the secondary school, as well as maths topics in the A levels. I'll also be solving mathematics past questions across these levels as we move along. So you'll be looking at arithmetic and reasoning SAT questions in the primary school. We'll also be looking at GCSE maths exams questions, as well as past questions in the A levels. So if you are new to this channel, I'll urge you to subscribe to my channel. Also hit the notification bell so that you'll be the first person to receive any mathematics video I'll put across there. Also like and share my videos to friends and relatives. Today, what are we looking at? We are going to look at how to derive the quadratic formula. How to derive the quadratic formula. Now, we know the general form of quadratic equation. The general form of quadratic equation is given as AS squared plus BX plus C equal to 0. This is the general form of quadratic equation. And then we are going to derive the quadratic formula from this general form of quadratic equation. Now the method we are going to use to generate the quadratic formula from the general form of quadratic equation is completing the square method. Completing the square method. Good. So we are going to use this method to derive our quadratic formula. Good. So how do you use this method to derive the quadratic formula from the general form of quadratic equation? Now the first thing to do here is to make the coefficient of the s squared to be 1. Make the coefficient of s squared to be 1. And to be able to do that, we need to divide each term in the equation by the coefficient of s squared, which is a. So divide each term there. Divide each term in the equation by a, the coefficient of s squared. Divide here by a, also by a. Now this a will cross out this a. We are left here s squared yes plus b on ax plus c on a equal to 0 by anything we know is 0, right? Good. Now, having made the coefficient of s squared to be 1, the next thing to do here is to take the constant term to the right side of the equal to sign. The constant term, we mean the term not attached with x, and that is c on a. And because it's positive here, as we move or transpose it to the right side of the equal to sign, it becomes negative. So we are going to have s squared plus b on ax equal to minus c on a. Minus c on a. Good. At this point, what do we do next? Now at this point, we are going to find half of coefficient of x. Half of, that is half times coefficient of x, which is b on a. And this will give us 1 times b, that is b, over 2 times a, that is 2a. So that is half of coefficient of x. And then we square this whole result or this whole answer. Now, so this b over 2a all squared that we are getting there, what do you do with it? We are going to add this term to both sides of the equal to sign here. So we add this to the left side, we also add the same thing to the right side. So that is going to give us s squared plus b on ax equal to minus c on a plus, oh, sorry, s squared plus b on ax, we add that term there, b on 2a all squared is equal to minus c on a plus b on 2a all squared. So this is giving us x squared plus, maintain the left side here for now, and then we simplify the right side of the equal to sign. So we square this fraction and then we add the answer, the result you see on minus c on a. So plus b on 2a all squared this is equal to minus c on a. Now the square is affecting both the numerator and then the denominator. So you are going to have b squared. So plus b squared over is 2a squared. So 2 squared a squared, and 2 squared will give us 4. Then this will give us a squared. A squared. Good. So at this point, we are going to add these two fractions, and then we factorize this left side of the equal to sign. Now, because we first find half of the coefficient of x, and then we squared the whole thing, and then we added to this expression. It's making this quadratic trinomial, is making it a perfect square quadratic trinomial. It's making this whole expression a perfect square quadratic trinomial. And there's a special way to factorize this thing because it's a perfect square quadratic trinomial. So how do you factorize that? Open a bracket here. We take the variable which is squared, and that is x. You bring your sign here, plus. Then the constant that is square, you bring that constant here, which is b on 2a. Good. Then we square this whole bracket. So this whole thing, we square it. Is equal to a space that is too small. Open a bracket, x plus b on 2a all squared is equal to. Now this addition of fraction, you find LCM, and the LCM is 4a squared. Yes, because 4a squared can go into itself, and a can go into 4a squared. So 4a squared becomes the LCM here. Now at this point, a goes into 4a squared. How many times? What do you mean by that? What it means is that if we divide 4a squared by a, 4a squared by a, that is a going into this, Then one of that, A will cancel one of this one, and then we are left with 4A, right? So A goes into 4A squared, 4A. And then we use this 4A to multiply minus C. So you're going to have minus 4AC minus 4AC plus 4A squared goes into 4A squared, 1. Then times B squared, that will give us B squared. Good. Now at this point, we are solving for X. We are solving for X in the equation. And once we are able to solve for X, that whole expression for X becomes our quadratic formula. Our quadratic formula. So how do you solve for X here at this point? Now, because this bracket is square, the bracket in which the X is in is square, so we must take out the square. And how do you take out the square? By giving square root to both sides of the equal to sign. So at this point, you are going to have S plus B on 2A all square. Then we give a square root here. And this is equal to square root of, we can just interchange the position of B squared and then minus 4AC so that the minus will go inside. So B squared minus 4AC all over 4A squared. At this point, the root will cancel out the square, and then we are left with X plus B on 2A is equal to. Now, this square is affecting both the numerator and the denominator, right? So we are going to have square root of the numerator and square root of the denominator. So square root of the numerator is square root of B squared minus square root of B squared minus 4AC all over square root of 4A squared. Square root of the denominator, that's square root of 4A squared. Now, this square root is affecting 4, also affecting A squared. So we're going to have square root of 4, that is 2. And then square root of A squared, the square will cancel the root. So you have A here. So that is that for this one. Beautiful one there. Good. Now at this point, we are solving for X. So how do you make X stand alone? By taking B on 2A to the right side of the equal to sign. So that's going to give us X equal to, it's plus, it goes here, it becomes minus. So minus B on 2A, sorry. At this point, you find a square root of anything is plus or minus, right? It's plus or minus. Whenever you find a square root of anything, it's plus or minus. So you have plus or minus here. So minus B on 2A plus or minus square root of B squared minus 4AC all divided by 2A. We have addition and subtraction of two fractions here. So let's simplify these two fractions by finding the LCM. So we have X equal to, find the LCM between this fraction and that fraction. The denominators, 2A, 2A. So the LCM is what? The LCM is 2A. Good. 2a goes into 2a times minus b. That will give us minus b. You bring out plus or minus. This 2a goes into 2a1 times the numerator. That will give us square root of b squared minus 4ac. Good. So we have been able to solve for x in that general quadratic equation. And this expression for x is our quadratic formula. So the quadratic formula is x equal to minus b plus or minus square root of b squared minus 4ac all divided by 2a. Good. So that is our quadratic formula. And we have been able to prove the quadratic formula. Thank you.